The frequent transportation of material and personnel is routine in the oil and gas, construction, and maritime industries. When material or personnel need to reach areas that are inaccessible by cranes or other movers, an air winch is an ideal choice. Also known as an air tugger or air hoist, an air winch is a machine used for the lifting, pulling, suspending, or tensioning of materials. When properly rated, winches can also transfer personnel between decks, floors, and other levels or structures. Air winches are frequently preferred to electric, diesel, or hydraulic winches because of their durability, versatility, and built-in safety features. Air winches are suitable for environments where fire hazards exist, since compressed air is used to power the winch, not flammable fuel. Air motors cannot burn out. They can be stalled all day without damage, making air winches ideal for tensioning applications. Despite having safer design features than other types of winches, air winches can still present hazards if safety procedures are not followed when selecting, preparing, and operating the winch. Winch selection. The process for selecting a winch begins with the job location. Regulatory agencies and requirements vary around the world, so be familiar with the regulations and company policies at each job site. Once familiar with the relevant regulations and policies, consider the weight and type of the load. When calculating the working load weight, include the weight of any load-attaching equipment, such as pulleys or blocks, that will be used during the operation. Each model of air winch has a maximum load capacity, which should never be exceeded during operations. Another element of winch rating is the type of load it can handle, materials, or personnel. Winches can be rated as utility, personnel, or dual-rated. Dual-rated winches are rated for either material or personnel, but must be used exclusively for either application. Utility winches are the most common and should only be used on material operations. Personnel-rated winches, commonly called man riders, should never be used to transport materials. Always ensure the winch is properly rated to support the type and weight of the load involved. Some situations may require the use of rigging or load-attaching equipment to properly handle the load. Slings, pulleys, chain hoist, or cable and chain pullers, commonly called come-alongs, can be used to help the winch move and position loads. Once all rigging and load-attaching equipment have been accounted for, a mounting site for the winch must be chosen. The mounting site must be a firm foundation, such as steel support beams. Foundations for man riders must be able to support 5 times the maximum rated load of the winch. The mounting site should be as level as possible. The slope of the site must have an angle of 15 degrees or less. The winch should have a support frame that can be secured to the foundation with heavy bolts or welds. If not, a frame must be attached. When the wire rope is not pre-spooled onto the drum, it is easier to spool the rope before the winch is mounted and secured. Always use the mounting bolts designed for the winch. If replacement bolts are needed, consult the manual for the proper grade or class of bolt. Never use screws to hold a winch in place. If welding a winch in place, ensure all hot work is done by a qualified welder. Position the winch so that the operator will have easy access to the hand controls, is always facing the load, and will never be positioned between the load and the winch. Winch operations should never interfere with other jobs or be stationed in areas where objects could fall and either injure the operator or damage the winch. Plan the load path so that the load does not travel over or near other personnel, workstations, or walkways. In situations where the load must travel over personnel, barricade these areas and post a watch to prevent entry until operations conclude. When choosing an air compressor, ensure that its output is compatible with the requirements of the winch. Air winches operate using compressed air, usually measured in pounds per square inch gauge, or PSIG. Most air winches are rated for 90 PSIG inlet pressure when the winch is running. The volume of air required for winch operation is expressed in cubic feet per minute, CFM, or cubic meters per minute, M cubed over minute. The air compressor's output must equal the winch's air consumption for continuous winch operations. The compressor's hoses and fittings should be sized equal to, or preferably one size larger, than the winch's inlet. Position the airline so that it does not create a tripping hazard, and also label the line so that it is not accidentally disconnected during use. Selecting the appropriate winch and compatible components is critical to safe operations. However, choosing the correct type of wire rope for winch operations is equally as important. Wire rope. Wire rope is comprised of three basic components. 1. Steel wires which form the strands. 2. Strands which are spiraled around the core. And finally, the core itself, which provides a foundation for the strands. All wire ropes have 6 characteristics which determine their suitability for a particular application. The first characteristic is the rope size, which is simply the diameter of the rope. Rope diameter is measured at the widest part of the rope. The second characteristic, rope classification, is expressed as 2 numbers, representing the strand and wire count. A 6 by 37 rope has 6 strands, each made of 37 wires. Higher wire or strand counts make ropes more flexible, but less durable. A 6 by 37 rope is more flexible than a 6 by 19, but is more prone to damage. The third characteristic of wire rope is its lay. Lay refers to the direction the wires and strands twist around the core. When the strands of rope run clockwise around the core, the rope has a right lay. Wire rope with a left lay has strands that run counterclockwise around the core. The direction of the wires that compose the strands can either run in the same or the opposite direction of the strands. In regular lay rope, the wires are laid in the opposite direction of the strands and appear to run vertically up the rope. Rope with a lang lay have wires that are laid in the same direction as the strands. Right regular or left regular lay ropes are usually recommended for winch operations. The fourth characteristic of wire rope is its grade of steel. Higher graded ropes are generally harder to damage and can handle heavier loads. Wire rope is manufactured in many grades, including improved plow steel, IPS, extra improved plow steel, EIPS, and extra improved plow steel, EEIPS. Extra improved plow steel is the most commonly used and manufactured grade today. The fifth characteristic of wire rope is its core. The 3 main types are fiber core, wire strand core, and independent wire rope core. Each type of core serves the basic purpose of providing support to the strands which surround it. The strands of fiber core ropes, FC, are laid around a core composed of synthetic material. Fiber core ropes provide the most flexibility and elasticity, but are more susceptible to crushing. Wire strand core ropes, WSC, have an additional strand serving as the core. A WSC is used in smaller ropes and is ideal for suspension and tensioning. Ropes with an independent wire rope core, IWRC, have a smaller wire rope which serves as its core. IWRC ropes are preferred in the offshore and construction industries because they are durable, flexible, and can function in many environments. The sixth characteristic of wire rope is its nominal strength. The nominal strength of a rope is simply the minimum breaking strength of a new, unused rope. The operating environment, working conditions, and type of job will help determine which type of wire rope is most suitable. Wire rope selection. Several factors must be considered when selecting the best type of wire rope for a job. An accurate appraisal of the following needs will help determine the best wire rope: the rope's strength, or its resistance to breaking, the rope's bending fatigue resistance, the rope's vibrational fatigue resistance, its resistance to abrasion, and finally, its crush resistance. High ratings in any of these 5 areas generally mean lower ratings in the others. Since a rope's nominal strength is its minimum breaking strength, the weight of the load should never approach this number. A working load limit is established for different winch applications, which protects the rope from damage during operations. To determine the working load limit, sometimes called the rated line pull for a particular job, the nominal strength must be reduced by a design factor. The minimum design factors for certain operations are as follows. The design factor for moving personnel is 10:1. For lifting, suspending, or lowering material, the design factor is 5:1. If material is moved by pulling or hauling, the design factor is 3.5:1. Therefore, if a wire rope has a nominal strength of 10,000 pounds and is being used to lift materials, the working load limit would be 2,000 pounds. All wire rope end connections and attachments, such as clips, hooks, slings, and shackles, must have at least the same working load limit as the wire rope. Design factors ensure that the wire rope and connections are strong enough to support the load if a damaging event, such as an emergency stop or shock load, occurs. Wire rope and winch manufacturers or employers may require higher design factors for certain applications. Always consult the proper manuals and regulations for the correct design factor if there are any questions or concerns. Normal wear occurs each time the rope is used and must also be accounted for. As the wire rope bends around the winch drum or a sheave, it is naturally worn down. The D-to-D ratio indicates if a wire rope will be excessively worn or damaged during normal operations. This ratio simply compares the winch drum diameter to the rope diameter. The D-to-D ratio is calculated by adding the winch drum diameter, capital D, to the wire rope size, lowercase d, and then dividing the sum by the wire rope size. For example, if a winch has a 24-inch drum diameter and a 1-inch wire rope is used, the calculation would be 24 plus 1, or 25, divided by 1. In this example, the D-to-D ratio is 25 to 1. Higher D-to-D ratios put less stress on the rope. D-to-D ratios which are too low will overstress and put excessive wear on the rope. The minimum D-to-D ratio for lifting or lowering a load is 18 to 1. For pulling or hauling operations, a 15 to 1 D-to-D ratio should be maintained. The minimum recommended D-to-D ratio for moving personnel is 22 to 1. The drum diameter can be found on the winch data plate, while the wire rope size will be located on the spool tag. Some winch drums can accommodate multiple sizes of wire rope. In these cases, the smaller sized rope will yield a higher D-to-D ratio. After confirming that the design factor and D-to-D ratio are sufficient, the rope can be carefully spooled onto the drum. Securely fasten the wire rope to the winch drum using the anchor screws. Never use synthetic fasteners. To prevent added stress and bending, the rope must always be spooled from the top of the reel to the top of the winch drum, or from the bottom of the reel to the bottom of the drum. Use a guide arm to direct the rope onto the drum. Do not touch the wire rope by hand while it is spooling. Keep tension on the rope so that it spools neatly and tightly. A braking action should be applied to the reel at all times when spooling the rope. There must be a minimum of 1/2 inch between the top of the drum flange and the top layer of the rope at all times. As the rope is being spooled, visually inspect it for any damage, deformities, or dry areas which lack lubricant. Lubricant helps minimize both internal and external corrosion, as well as damaging friction. If no damage or dry areas are found, lift preparations can begin. Safe air winch operation. Safe air winch operation helps protect not only those directly involved, but all those at the work site. Safely operating an air winch can be summarized by completing 4 simple steps: performing a job safety analysis, inspecting the winch and wire rope, following safe operation guidelines, and maintaining the winch and wire rope. Step 1. The first step of safe winch operation is performing a job safety analysis, or JSA, and obtaining a work permit, if necessary, before the job. A JSA identifies the potential hazards of each winch operation, then introduces steps to eliminate or reduce these hazards to an acceptable risk level. The JSA should include, at a minimum, load weight, safe working load, equipment capacities, hand signals, personnel location, the load path, and PPE. Any job-specific PPE will be reviewed during the JSA, but hard hats, safety glasses, steel-toed shoes, and tight-fitting gloves must be worn during all winch operations. When moving or suspending personnel with the winch, a secondary means of fall protection must be worn at all times. Properly worn clothing is also important during winch operations. Loose-fitting clothing or untucked shirts can snag on or get caught in winch equipment. The JSA should also contain weather conditions and any other factors or hazards which could affect winch operations. Once the JSA is completed, signed, and a work permit is issued, inspections can begin. Step 2. The second step of safe winch operation is inspecting the winch and wire rope at the correct intervals. Performing and documenting regular inspections can uncover problems before a serious accident occurs. If the winch or wire rope fail any aspect of an inspection, they should not be used. An initial inspection must occur before the first use of a new, reinstalled, altered, or modified winch. The detail and frequency of future winch inspections will depend on how often the winch is used and the degree of wear it is put through during operations. Visual examinations must occur at least monthly for winches in regular service. These inspections are known as frequent inspections. Examine all control mechanisms for any indications of damage or excessive wear. Inspect all limit switches or limiting devices each shift to ensure they are working properly. Check for any deterioration or leakage in the compressed air system, including all connections and fittings. More detailed inspections, called periodic inspections, must take place at least yearly for winches in normal service. Periodic inspections must be maintained and documented to include the working condition of the winch. The frequency with which wire ropes should be inspected also depends on the work environment, manner, and how often they are used. Wire ropes in continuous service must be inspected before the first use, before each shift, or more frequently, depending on work conditions and past experience. During frequent inspections, survey at least the amount of rope that is expected to be used that day. To properly inspect the rope, unreel it onto a smooth, hard, and clean surface. Dirt, water, sharp objects, or uneven surfaces can damage or reduce the lubrication of the rope. Once the rope is unreeled, begin looking for abnormal wear, physical damage, or other deformities. External damage is the easiest type of damage to recognize when inspecting wire ropes. Visually inspect for any of the following rope distortions: excessive wear, abrasion, fatigue, gouging, bird caging, core protrusion, kinks, knots, crushed sections, bends, broken strands, or broken wires. Inspect the rope in lay lengths. A lay length is the distance it takes for one strand to make a complete spiral around the rope. Lay lengths can be measured to gauge how much the wire rope is stretched. When lay lengths exceed the safe stretching limit from the wire rope certificate, remove the rope from service. While individual broken wires can be dangerous, broken wires protruding from between the strands, called valley breaks, can be an indication of core failure. Within a lay length, the rope should be replaced if there are 3 or more broken wires in one strand, 6 or more randomly broken wires, or 2 or more valley breaks. Also replace the wire rope if there is a significant reduction in diameter. The maximum allowable reduction in diameter is determined by the original rope size. Other forms of external damage, such as heat damage, can be detected when inspecting wire ropes. Signs of heat damage include dried out lubricant, brittle and rusty sections of rope, black charcoal flakes, or discoloration. Unlike external damage, internal damage, including rust and corrosion, is not always visible and is harder to detect. Dry or unlubricated areas on the rope or end connections can also be warning signs of internal damage. Inspect wire rope slings in the same manner. Within a lay length, slings must be replaced if there are 5 broken wires in one strand, 10 randomly broken wires, or 2 or more valley breaks. Nylon slings must be replaced if there is any visible damage, such as wear or frays, or if any sections are discolored or feel rough and brittle. During periodic inspections, or if there is a potentially damaging event, such as an emergency stop, the entire length of rope must be surveyed. Once the rope inspection has concluded, examine the hook. Ensure it is not damaged and is not twisted more than 10% from its original plane. The throat opening must not have increased more than 15% from its original size. Check all load attaching equipment and rigging for damage, and ensure the work area is clear and free of debris. Once all components have been inspected, carefully re-spool the rope around the drum. Winch operations can now begin. Step 3. The third step of safe winch operation is following safe operating guidelines before, during, and after each operation. Winch operators must always be qualified and trained to operate their winch. Before job operations begin, verify that the signal person will be visible at all times. Ensure the throttle and brake handles are operating smoothly before attaching a load. If all controls are functioning properly, perform a load test before the initial use of a winch. or when operating an altered, modified, reinstalled, or repaired winch for the first time. Properly rig a load weighing between 110 and 125% of the winch's rated load. Make sure the load is in the center or saddle of the hook. Slack the line or move the load to adjust the rigging, but never tip load the hook. During a load test, the operator must hoist the load and assure that the load is completely supported by the brake. The test load should then be lowered, stopped, and safely held by the brake. Lower the load slowly to ease out the slack, then continue at a steady pace. Never jerk the rope. Regulations require that at least 2 full turns of rope remain on the drum during the entire operation. However, many companies require a higher standard. The operator must focus on the environment and load, ensuring the load never passes near personnel or workstations. Use barricades or designated personnel to prevent entry into the area. All personnel, including the operator, must stay clear of moving loads at all times. Anyone may give the emergency stop signal to the operator. However, only the signalman may relay other commands. When the winch will be left unattended or operations concluded, the winch and load must be secured. Fully land the attached load, disengage the clutches, set all controls in the off position, and set the brake. Safely operating a winch does not end with performing inspections and safe operating procedures. The winch must also be properly maintained at regular intervals. Step 4. The fourth step in safe winch operations is proper winch maintenance. Maintenance helps prolong the life of the winch and helps prevent accidents from occurring. The maintenance program should be established according to the guidelines located in the winch manual. Only authorized personnel should perform air winch maintenance. Winches undergoing maintenance must be isolated from all energy sources, preferably through lockout-tagout procedures. When maintaining wire rope, follow the manufacturer's recommendations for lubrication based on the environment and use of the rope. If additional lubricant is needed, unspool the rope and apply it with a paintbrush to the dry areas. Never attempt to repair or modify a wire rope or hook in any way. If either are damaged, replace it immediately. To prevent damage to unused wire rope, store in a cool, dry place, away from moisture, excessive heat, ocean spray, or other corrosive atmospheres. Ensure wire rope is clean, well lubricated, and carefully spooled before storing it. Use protective wrapping, such as cellophane, if the rope will be stored for long periods. Always keep accurate records of air winch and wire rope maintenance. An air winch is a safe and effective tool for lifting, pulling, suspending, or tensioning in many environments. To safely operate, select the most appropriate winch and wire rope for the job. Thoroughly inspect the winch and rope, perform scheduled maintenance, and obey all safe operating procedures. If there is ever a concern over safety, use stop work authority. Safety issues concern all employees. Air winches are durable and reliable machines. Their proper and safe use will prolong the life of the winch and help prevent accidents and injuries.